Okay, so for part C, D, and E, it says it is decided to perform a chi-squared goodness of fit test at the 5% significance level to decide whether the stopping distances of bicycles can be modeled by a normal distribution with mean 6.76 and standard deviation 0.12. State the null and alternative hypotheses. Okay, so the null hypothesis, which is our H0, is that the stopping distances, or the breaking, well, it's stopping distances, we're going to assume they can be modeled. So the stopping distances can be modeled by a normal distribution. Now guys, you have to include this in it. You can't just say that it's normally distributed. It's that it's normally distributed with a mean of 6.76 and a variance of 0.12 squared. And then the H1 is that they cannot, stopping distances cannot be modeled by a normal distribution again of this, because even if it was normally distributed with a different mean and a different standard deviation, you would still reject the null hypothesis. So it's not any normal distribution, it's this very specific normal distribution. We know that because it says it. It says the test is to see whether it can be modeled by a normal distribution with mean this and standard deviation this. So our H0 is, okay, yeah, fine, it can be modeled with this, and our H1 is that it can't. Okay, part D. Find the p-value for the test, right? So this is the bit where we actually have to do some work. We need to find, so these were the observed number of bicycles. We need to find what the expected number of bicycles were. Now we did find these in the previous questions. So let me just go back up here. Between 6.5 and 7.5, we had 451.7. So this one was 451.7. Between 6.75 and 7, it was 510.5. 510.5. Now we didn't actually get these expected values, but we're just timesing it by 1,000. So this is 15.1 and this is 22.8. So this is 15.1 and this is 22.8. Okay, so there are marks going for these guys, so just make sure you put in those. You'll need to put them in here anyway into your calculator. Okay, now we go menu, statistics, stat tests, and chi-squared goodness of fit. Now they want an observed list and an expected list, and I haven't actually given any, so we need to open a spreadsheet and add in some numbers. Okay, I'm going to call this observed, and I'm going to call this one expected. Okay, so our observed is 12, 4 to 8, 5 to 7, and 33. And our expected is 15.1, 451.7, 510.5, and 22.8. Now I can run the statistics test. So menu, stat test, chi-squared goodness of fit. Now my observed list is what I've called observed. My expected list is what I've called expected. Note guys, because I could call it O and E, fine, but because I've called it observed and expected, it's very clear which one to put into the observed list and which one to put into the expected list. The degrees of freedom is one less than the number I have here. So it's 1, 2, 3, 4. It's 4 minus 1, which is 3. So the degrees of freedom is n minus 1. That's the rule. So it's 3. Results column C, fine. The p-value is 0.072654. P-value is 0.07, what did we say, 0.72654, 2654. If you want to 3 significant figures, 0.0727. State the conclusion of the test and give a reason for your answer. Okay, so it's a 5% level of significance that they're after here. What does this mean? P-value of 0.0727. Well, it means that these results, if it was a normal distribution with mean 6.76 and standard deviation 0.12, and you got these results, it means they're not that unreasonable. There's approximately 7% chance that you would get results this extreme, let's say. And because as 0.0727 is bigger than 0.05, which is our level of significance, we do not have enough evidence to reject the null hypothesis, so we fail to reject the null hypothesis. Okay, that's it, guys. Hope that makes sense, and I'll see you in the next video.